Alright guys, so on this page we're going to do basically one of each example. We'll probably just do that, and then you can do the other example on your own and you can check with the key on Canvas, okay? So for this first one here, I'll do for you guys. So find the magnitude and direction. Scratch this off here. I'm just going to make it a little harder for you guys, okay? So -3, -6. So a very important thing, you need to sketch this, okay? So to sketch this vector here, so just draw another coordinate plane. Boom. That doesn't look straight for some reason. Oh well. So -3, -6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Boom. So it's like right here, okay? So this vector, we call it vector A. Boom. Call it vector A. Okay, -3, -6. So now what we need to understand though is that this starts at 0, 0, right? We know this starts at 0, 0, and this here starts at ends at -3, -6, right? Okay, so that's the vector form. Now to find the magnitude, okay, remember magnitude just means distance formula for our case. Anytime you see the word magnitude, it means find the length, aka use the distance formula. So obviously it's pretty easy. You can just even get used to doing, because you can just ignore the zeros, right? -3 squared plus -6 squared equals, let's call it, D for distance for now. You can get 9 plus 36. That's going to equal radical 45. Radical 45, can I break that down? Let's do over the side here. 9 and 5. 9 is a perfect square. Circle that. That goes to the outside. Square root of 9 is 3. Radical 5. Okay, and that should be your distance, okay, or your magnitude. In terms of magnitude, you probably want to label it like that. Okay, just to be formal. So the magnitude of vector A is 3 radical 5. Okay, so hopefully it's not too bad, right? Magnitude, hopefully it's pretty straightforward on how to do that. And then direction. Okay, so here's the tricky part. For direction, remember when we talked about how this here is the original position. Okay, that's the original position. So I'm going to put a pin there. Your goal right now is to find this angle. This angle right here, right? Because you can form a right triangle. This is now a right triangle. The distance of this is 3. The distance of this is 6. Okay? So let's check here. Or more specifically, it's like -3 and -6. -3 and -6. Okay, make sure you put the signs. Okay, that's gonna help you with your answer. So for direction, I should probably use tangent, right? Tangent of the angle equals opposite over adjacent. Make sure you take the inverse, -6 over -3. Yes, in the end, the negatives will cancel out, so it's basically just a positive. Please put this in your calculator right now, or I can show you. I can show you. 6 divided by 3, right? Boom, that's 2. Let's find the inverse tangent. 63.4 degrees. Okay? So, it turns out if you stop here, you're wrong. Okay, why are you wrong though? Why are you wrong? So that's part of the answer. You're halfway there. Look here, okay? This is all visual here. Can you grasp this conceptually? This here is your starting position. If this is your starting position, how much did your vector actually move? Look at that. Boom. Okay, do you see that? You start here, that's your standard position, and your vector moved all the way here. So technically speaking, your official angle from here to here, that's the angle that you need to find. You found the baby angle, right? This here is your baby angle. And that angle was 63.4, right? So now how can you find the total angle? So pretty cool stuff here. Let me show you guys this. This here is 0 degrees, right? You start at 0 degrees. If I have an arrow here, let me do a green arrow. Do you see his arrow? So if I start here, this is 0 degrees. If it opens up to this, what shape is that? Let me make a better arrow. Ooh, boom. Okay, from here to here, what degree is that? Boom, boom. Okay, that's 90, okay? Pretty cool, I'm gonna write 90 here. 90 degrees. Okay, shoot. Oh no, I wanna turn it. There you go, that's 90. So 0 to 90, what about to here? What is this? When you go from here all the way over here, that's gonna be 180, right? A straight line, right? You think about this, this is a straight line, 180 degrees. Essentially, you turn it one more time, boom, 270, because you keep adding 90 degrees. You guys kind of see that? This here is 90, this here is 90, this here is 90, and then you add 90 again. It's kind of neat. This here ends up being 360 degrees, okay? Boom. Right, a full circle, right? A full circle gets you back to 360. Whoa, isn't that cool how everything's connecting in life now? 0, 90, 180, 270, 360. Okay? So, you did find this angle again. This angle here was 63.4. But now I should take that and what should I add to it? You should add 180. Because you went from here, that's 180, and you went a little bit more to there. And now your total direction is 243.4 degrees. Boom. Okay, that's your official direction. Okay, pretty good. Pretty good, pretty good. All right. So go down to the bottom here. We'll do the problems in the middle soon, but go down to the bottom. Okay, scratch this one off for me. We're not doing this one. I don't think we are. Yeah. Write this one instead. -5, -2. Okay. And why don't you guys right now please try to find the magnitude and direction for this specific vector. You can just use this graph here. And just check out the last example and see if you can get the right answer, okay? So hit pause now. I'm gonna show you the answers. So just hit pause. When you're ready, hit play. All right, so kind of follow along here with my answer. Magnitude, radical 29, okay, the work is there. Again, -5, -2. Drawing the picture is very important, so make sure you draw the right vector and understanding your coordinates and how it forms that right triangle, okay? Boom. That's your vector. For your direction, okay, you find the angle here, that purple angle, this angle right here. Right from here to here, you should use tangent, and it's 21.8 degrees. But of course, you're not done yet, right? You have to add it with the 180. Plus 180, your official direction is 201.8 degrees. Okay. So again, double check that. I'm gonna go on to do the next couple of examples here. We'll just do both of these and then we'll call it. So these are a lot easier. The hard part you just did. This is just adding, subtracting here. If you're given a vector with just 2 points and you need to write it in component form, remember component form is the x minus y. Your formula for this is x2 minus x1, comma y2 minus y1. Okay, you might want to like box this, highlight this or something. I just find the difference here. So I have, your x2, this is specific though, x2 and y2 is always your terminal point. So these aren't random anymore. Okay, make sure you use the right ones. x2 and y2 is your terminal point, and then x1 and y1 is your initial point. 4 minus 1, comma, 3 minus -1. In the end, your answer is 3, 4. Yay. You can try this next one later, and I'll show you guys the solution. For number 3 here, find the following. Find each of the following. Vector A is that, vector B is that, and vector C. Check your answers graphically. So here's how you do it algebraically. It's literally just like algebra. So you have 2 times vector A, right? In this case, what is my vector A? Vector A is 2, 4. Plus, what's my vector B? 3, negative 3. Okay? You literally distribute this, so that's a fair move. 4, 8. Plus radical 3, negative 3. Now you have to add this component-wise. So you add the x's, 4 plus 3, 7. You add the y's, 5. Okay, so that would be your final answer. A pretty neat thing, you can graph this and it works out. So this here is 2 vector A, right? What I just circled, 2 vector A. So if I graph that, 4, 8 is here. Boom. This is 2 vector A. And then the plus B is here. So starting from here, I'm now going to go up 3. Right 3, down 3. So right 3 is 7, down 3 is 5. That's right here. Boom. So that there is vector B. And in the end, where did you end up? This is your resultant. This is 2A plus vector B. What is this coordinate here? What is that? That right there is exactly 7, 5. Beautiful, huh? Alright, so feel free to hit pause. You can try 2 and 4 on your own. Solutions, I'll just put them here. They're also on Canvas. Okay, you can kind of look at it over here. Other than that, good job. Keep working hard in everything that you do.